Welcome to your tutorial on descriptive statistics. First, I'll show you how to calculate your descriptive statistics in SPSS. Okay, so today we're looking at descriptive statistics and running those in SPSS. So there's actually two ways that you can get your means, your standard deviations, your skewness, your kurtosis, etc. So one is actually through Analyze Descriptive Statistics and then Frequencies, and the other is Analyze Descriptive Statistics and then Descriptives right here. So I'll actually go through showing you both of them. So the first thing we want to do is we want to keep in mind that we need different information depending on the type of variable we have. So for example, our categorical variables, so we have sex and program, or what type of program people are registered in, as well as pass and fail. Those variables, we're not really interested in calculating the mean and the standard deviation on those because it's going to be useless. But we are interested in the frequencies, so kind of how many of each category there are, and then how those correspond to percentages. And then we're also interested in the most popular category, which would be the mode. So we're going to be looking at different things for the different types of variables, whereas our continuous variables, so whether they're ordinal or interval or ratio, those ones we're going to be interested in calculating, mean, standard deviation, looking at the range, as well as the shape of the distribution, so skewness and kurtosis. So what we'll do first is I'll show you how to get the information you need for the categorical variables. So for this one, it's actually better to do it through Analyze, Descriptive, and Frequencies, because this is how you can see how many people or how many data points fall into whichever category. So we're going to do frequencies, and we're going to pick all of our categorical variables here. So we have our numeric ones. And then what we want to do is make sure this box here, Display Frequency Tables, is selected. So this actually got mad at me because by unselecting that, I actually have nothing selected now. So I click this, and then under Statistics, this is where you get to pick what you actually get. So if you recall, none of these are useful except for the mode when we're looking at categorical data. And then the percentile values are also not going to be useful, nor will the dispersion or any of these other ones. Okay, so a categorical variable, really the only thing we need here is the mode. Charts, we can ask for a bar chart, which is going to just kind of visually show which groups are where. And we can go by percentages or frequencies if we want. Format, we can just leave that as the default. And then the style, again, this lets you kind of go a level beyond and customize what your tables look like. You don't need to worry about that. And then bootstrapping, we also won't worry about that. So essentially just in these first two. So then you click OK. And now this output window is going to open. And instead of closing it, we want to actually pay attention to what we have. So the first thing we have is a little summary table here telling us how many how many of each group, of observations there are per variable. So we can see that for all three, we have 50 and no missing. So it means in our sample of 50 participants, there were 50 valid scores for sex, 50 valid scores for program number, and 50 valid scores for pass-fail. So what we can see here is that in the case of the program number, multiple modes exist. So what that means is that there's a tie for the category that appears the most often. And then for sex and pass-fail, the mode is 1. So the problem is you have to remember what 1 was coded as. So if we look back here, if we're going to go to variable view, we can see that for sex, 1 was female, and that for pass-fail, 1 was pass. Okay, so that's why, again, the mode can be a little bit tricky, and sometimes it's better not even to bother looking at that and just to go right down to your frequency tables and just see which is the most popular category. So the frequency tables are super helpful for categorical data because it gives you the number of observations per category, as well as the percentage those make up. So if you were to turn it into, say, a pie chart or something, this is how you would allocate those percentages. And then it also does something called the valid percent, which right here I don't have an example, but I'll give you an example in a second, where what it does is adjust the percentages and by removing any missing data. So if you had missing variables right now, those would show up as part of this, but then it gives you an adjusted one. So as we can see here, women made up 58% of the sample with a frequency of 28. Men were 40% with 20, and then there were 2 people who were 4% of the sample who decided not to disclose. We have the same thing here. We can see that in the specialization, there were 20 students, the minor 10, the major 20, and their respective percentages. And then finally for pass-fail, we can see that 6 students failed the class and 40 passed. So, and their percentages. So if you get the bar chart, basically it's that same information, but visually. So in a bar chart, the column that's the highest is your mode. If you have 2 modes, there'd be 2 columns that are tied, as we see right here. And then finally pass fail. So now I'm just going to show you an example with the valid percent issue. So you don't need to save this. So I'm going to I'll do it in the sex variable here. I'm just going to delete a bunch of scores. Okay, and it's not letting me. Oh, it's because I'm on this view. Sorry. It's easier to delete them. All right, so now I'm going to rerun the same thing. Okay, and now we can see that we have scores missing. So I didn't code those as 99. I can. It'll still interpret them as missing, but I can put the code in. But either way, what I want to show you here was that now these percentages have been adjusted. So 18 males represents 36% of the sample. However, once you adjust for the scores that are missing, it's actually 41%, etc. So that's what the valid percent looks like. Okay, so that covers the categorical variables. So now for our numeric variables, we need to actually calculate, we need to have more information. We need to know the means, the standard deviations, the range, and then the shape of the distribution about whether, it's skewed or there's issues with kurtosis. So again, we can do that through the same option here. Basically, the difference is that one of the outputs is going to put everything horizontally, and then the other one is going to put it vertically. The difference here too is that we can ask it to display those frequency tables. So let's go with our age, year, and then we'll only look at our overall scores here. Oops. Okay, so we're there. So in statistics, we can select now that we no longer want the mode, but we do want the mean and the median. We want the standard deviation, we want the range. And we can also ask to have the lowest and the highest values. This is going to be redundant because right now we also have the frequency tables being displayed, which is also going to show us that. And then we're also going to ask for the skewness and the kurtosis. Under charts, this time a bar chart is not appropriate. We'd want to get a histogram. So we can put that there. That'll come out. We'll look at those more another time. Format, we'll leave everything the same. I'm not going to click style again because it opens that weird window, and bootstrap, we won't have anything either. So this time I click OK. And as you can see, it's creating kind of a really big table with all this information underneath here. So what we can see for age is that we have all the data points there. Year, we're missing a participant. Test total, everyone. Overall motivation, everyone. So we can see the mean age in our group is 21.4. The median is 21. Standard deviation is 2.6. So that means that 60% of the population, or the sample rather, falls between 24 and 18-ish. Okay, so I'm just doing 21.4 plus 2.6 and minus 2.6. So we can see our skewness is a positive value, and it's a bit higher than 0.5. So if you recall the cutoff values, anything between 0 and 0.5 is considered to be no issue. 0.5 and a 1 is like moderately skewed, and then anything over that 1 here is going to be highly skewed. So in this case, since it's a positive value and between 0.5 and 0.1, we'd say it's maybe moderately skewed. Same thing for kurtosis. So this is a positive value, so it means that the shape is more pointy, and again, because it's between 0.5 and 1, we'd say it's moderately. And since this is a positive skew value, it means that the distribution has more scores at the bottom of it and then kind of tapers off this way, whereas a negative skew would have more on this side and less at that end of the score. And then we can see that the range is 12 and that all the scores fell between 18 and 30. So we can see the same thing kind of in all these values, except you can see here that the total test score has a negative skew. So it means that there was more high scores on the variable the variable than low scores, which makes sense because we had more people passing the exam than not. And then same with the kurtosis. So it means it's actually a little bit more flat. And this time it's a problematic one. Okay, so it's a lot bigger than 1, but it just means that the distribution is pretty flat. And then you can see the same information there for overall motivation. So the frequency tables, this is up to you whether you like to look at them, but it just gives you an idea of kind of where people's ages fell, what year they were in. So I'm realizing now this should have been probably looked at as a categorical variable. I forgot that it was just these two. So this should have been looked at as a categorical variable, not a, and if we look here, yeah, so it's like not very interesting. So so year should have been categorical. And then we've got motivation and total test. So we can see the most popular score was kind of just a pass, so with a 11 on 20. Anyway, and then we can see here the observation. So you can see that like this had a negative skew slightly, and that's because more scores appear at the bottom, and then it kind of tapers off towards this end because this person that's 30 is kind of really changing the shape of the distribution. For year, disregard this. This should have been looked at as a categorical variable. And then finally, total test. We can see that it kind of has that normal distribution shape, but there's a lot more people here than maybe here for a completely normal distribution, which is why if we look up there, we can see that we do have some issues with at least the kurtosis, whereas the skew is okay. So it's just that it's a little bit it's not filling out that bell shape in the way it should. And then for overall motivation, we can see the scores are there's really no one in the middle, and it's not at all like a perfect distribution, and that is reflected here in that we've got the really high issue with the kurtosis, and even though the skew is low, it just means the scores are kind of equally distributed on both sides of the mean, which they are, but this is talking about how the shape is really not a bell curve shape. So essentially, that's how you get all your descriptive statistics through that output. And now I'm essentially just going to show you the same thing, but using the other window. So, oops, this is really big. Okay, so Descriptive Statistics has an extra option down here to save the standardized values as variables. So don't worry about that. But essentially here we'll look at age, not year, because it should have been categorical, and then the two test scores. And this time here you click options and you can see it's already assuming you're looking at numeric data. So it's got your mean already picked. It's got the standard deviation, the minimum, the maximum. So you can calculate your range on your own or ask it to do it. And then you want to add the skewness and kurtosis. So you notice here there's no option for the median, there's no option for the mode, and that is because really in most cases those aren't very interesting if you're looking at numeric data. So the only time the median is really important is if you have really high kind of skewness, then you want to know where the true center is. So that's like on financial data or something. So we click OK here, click OK down here. And essentially we get the same information, but this time it's on this kind of obnoxious like horizontal output. So it's really up to your own personal preference what you prefer, but it's the same information. So you have the number, you can see the range, the minimum, the maximum, the mean, the standard deviation, and then you have those skewness scores here, and those kurtosis scores here. So essentially the same thing, just a different orientation, and it's kind of up to your own personal preference which one you prefer. So yeah, so there's that. Next, I'll show you how to calculate reliability. Okay, so the next thing I want to show you is how to calculate the reliability of a measure, and you would do this before, or you should do this before you calculate a total score. So our motivation score, we should be first checking to make sure that these four measures are reliable with each other. So if you recall, these corresponded to 4 questions about how motivated you were to study statistics, where one of them we had to recode it because it was a negative item, and in order to put it on the same scale as the others, we made it a positive item. And sorry, I'd already adjusted this and then I forgot to save the name, so sorry. So this one had been recoded. And what we want to make sure is that these are all measuring the same thing before we actually calculate this motivation score. So I'm showing this to you in the wrong order, but this is something that you will need to be able to do for your final assignment. So what you do is you go to Analyze, Scale, Reliability Analysis. And this is where you would put all the items in. So you have motivation 1, motivation 2, the recoded one, 3, and 4. And essentially, you don't have to select anything other than make sure that this is on alpha. So this is going to calculate our Cronbach's alpha, and you can give it a label here if you want, motivation. And then under the statistics, we don't actually need to hit anything. So we just click OK. And we get our little output. And essentially, it tells you right here that the Cronbach's alpha is 0.96. So this is excellent. This is very high. Almost maybe too high. So if you recall, kind of the different, anything under 0.5 is like terrible. 0.5 to 0.6 is poor. 0.6 to 0.7 is like, I'd say weak. And then over 0.7 is acceptable, 0.8 is good, and then 0.9 is excellent. So those are the cutoffs there. Finally, now I'll introduce you to the SPSS syntax editor. Okay, finally, I'm going to introduce you to something called the SPSS syntax window, and this is just something that will make your life a lot easier. So the easiest way to create a syntax window is to click New and then click Syntax. And what it does is opens this kind of blank notebook. And how it works is that if you put an asterisk at the front of a line, you can write yourself notes. So I could be like, hello, Meredith. And then I end it. And then as long as I keep typing until I have a period, it's going to stay in like note form. So if I do this, we're out of that. So what's nice about the syntax editor is that you can kind of keep a log of the analyses you're doing. And then if you need to go back and do them again, it's a lot easier just to run the syntax than it is to click through all the options. So let's say, for example, I'm calculating my descriptive statistics for categorical variables. So what I need to do is go back into here. We'll grab our frequencies. I'm going to reset this. So I'm going to grab year this time. So I've got age, year, program, and pass fail. And if you recall, I wanted to only have the mode, and then I wanted it to make a bar chart. So this time, instead of clicking OK, you click paste. And what it does is it automatically pastes this into, so sorry, I just deleted that. You can delete this thing that says data set activate data 1. And now suddenly I have this right here. And if I want to run that analysis again, instead of having to go back and click analyze and do all the things, I can literally just highlight it and click this green button. And then I have my exact results. And there they are. The same thing we did earlier, but faster. Okay, so I can close, don't have to save the output window, or you can, it's up to you. And then maybe here I want to do my Chromebacks alpha for motivation. So I made myself a little note. I'm going to go to Analyze. I'm going to go to Scale, Reliability Analysis. And this time again, instead of clicking OK, I just click Paste. And then here we go. And then highlight that. There she is. Look at that. All right, then let's say now we need our descriptive statistics for numeric data. So this time I want to go into descriptives. We'll use the descriptives panel, and it's still set up, but that's great. But if I'd done other things, it'd be gone. So I click paste. There it is. And so now if I want, I can actually just run all of it at once. So it's thinking, but here it is. So suddenly in like one quick little jump, I can redo everything. So in terms of your final assignment and kind of keeping track of your work, this is a much easier way to kind of have a log of what you did. And you could be like, you know, if you're really, really organized, you could do something like project goal number 1 or number 2, and then put, you know, the relevant analyses there. And then like, you know, project goal number 3, and put them under here, and basically have this nice little document that along with your data file, those 2 documents will allow you to access everything you need for the entire semester without kind of losing your work, or if you screw it up somehow, it's easy just to start over and not forget what you did. So I strongly encourage you to use the SPSS syntax window and then our editor, and the same thing, you just save this and it's another type of file. So you'll have this. Okay, that's that.